I'm Akhil, and on this channel, I break down my weekly learnings from IIT Patna's Generative AI program. Let's dive into today's topic. What actually happens inside ChatGPT when you press enter? And why does Claude sometimes confidently make up things? And what on earth is an agentic AI workflow? So I just started a course on generative AI and I am documenting everything I learned for myself and for anyone who wants to learn alongside me. So this is module 1, week 1, the foundations. By the end of this video, you will understand how modern AI actually works, from the difference between AI and machine learning, all the way to AI agents that can use tools on their own. Let's get into it. The first thing that clicked for me is that these buzzwords aren't competing terms. So they are nested inside each other like Russian dolls. Artificial intelligence is the biggest umbrella. Any technique that makes a machine smart, like machine behave smart. So inside that is machine learning. Instead of hard coding rules, you let machine learn patterns from large amounts of data. Inside is deep learning. Machine learning using neural networks, which are big webs of nodes and connecting loosely inspired by human brain. These can learn really complex patterns. And finally, sitting inside is generative AI. Models that don't just classify or predict, they create, like the text or images, audio, video, and code as well. So whenever someone mixes up these terms, just remember every generative AI model is a deep learning model, and every deep learning model is machine learning, and all of it is AI. So how we actually got here, because the history makes it make sense. Back in 1970s and 80s, it was mostly rule based. Like humans wrote if then that rules by hand. These are powerful for narrow problems, but brittle. So the moment when you hit a situation where no one wrote a rule for, it broke. And then came classical machine learning, where systems learn patterns from data instead of relying on handwritten rules. This powered things like spam filters, fraud detection, and recommendation systems. And then the deep learning era arrived with neural networks that could handle images and speech. Uh, these are text to speech and image recognition. And then in 2017, a paper introduced the transformer architecture, which unlocked today's large language models. And now we are entering the agentic era. So multimodal models that don't just answer, they take actions, use tools, and complete multi-step tasks on their own. This jump is what this whole course is building towards. Okay, let's look at different models. You don't need to memorize the specs, but it helps you to know the main players. Uh, ChatGPT from OpenAI, the model that put generative AI on the map for most of the people, and Claude from Anthropic, known for being strong at reasoning, writing, and large, careful instructions. So right now, this is what me and most of the people in the world right now are using. So now the Claude has overthrown ChatGPT. Uh, yeah, but this game is highly volatile. So new model coming up every day. Let's get into the thing. So next, Gemini from Google, uh, deeply multimodal and tied into Google's ecosystem. Next, Llama from Meta, one of the most popular open models, which matters for the next slide. Okay, and Mistral from the Finch lab of the same name, known for the efficient, high-performance open models. So the key insight, these aren't the same kind of products. Some you can access through a company's API, others you can download and run yourself on your own hardware. This is one of the biggest debates in AI right now, open source and closed source models. So first, let's look at the closed source model like ChatGPT, Claude, and Gemini. They live behind an API. You send a request and you get a response, but you can't see the weights or you can't run it on your own hardware. The upside is they are maintained and easy to use. The downside is the less control and the ongoing cost, and data leaves your machine, so data is not private. And coming to the open source models like Llama and Mistral can be downloaded, inspected, and fine-tuned and also run privately. So the upside is you can control them, the privacy, because data doesn't leave your system, customization, you can tune the model as per your requirement, and no per request fee since you run it locally on your hardware, so you don't need to pay for any API fee. So you need hardware to support the model and how to run it. And very top model capabilities often still belong to closed models right now. So here there is no universal winner. It genuinely depends on what you are building, your budget, and your privacy needs. Okay, theory aside, why does any of this matter? Because the generative AI is already everywhere, especially for the messy, open-ended problems that rule-based systems just couldn't handle. So in coding, it writes code, it explains the code, and it also debugs the software. In healthcare, it summarizes records and supports diagnosis and the research. In finance, it powers fraud detection and risk analysis. So in customer service, it runs chatbots that actually works. And also recently, the voice agents also come up. So it understands the context clearly, just like a human being. And in automation, it handles repetitive knowledge work, drafting, summarizing, data entry, etc. And in media, it generates images, videos, code, audio, and everything. So the common thread, anywhere a task is complex, open-ended, or needs a natural language, generative AI is finding home. Now let's open the hood. This is my favorite part of lecture. So when you type a sentence, the model doesn't see the words the way we do. So the first step is tokenization. The text gets broken into small chunks called tokens. A token is often a subword, not a whole word. For example, the word unbelievable might be split into unbelievable. So why? Because breaking the language into reusable pieces lets the model handle any word, even which it's never seen, by combining familiar fragments. So a rule of thumb is in English. So a rough rule of thumb in English, one token is about three quarters of a word, or roughly four characters. Everything the model reads and writes is measured in tokens, not in words, which matters a lot for the next concept, which is the context window. The context window is model's short-time memory. Means the maximum number of tokens it can see at once, including both input and its response. So think of it like a model's disk. Everything it's working with has to fit on the disk. So if the conversation is too long, the earlier stuff falls off the edge, and the model effectively forgets that. So the modern models have huge context window, hundreds and thousands, like currently even 1 million tokens, which is why you can now feed the entire documents, a long conversation. But you need to remember that it's not infinite, and understanding its limit explains a lot of weird AI behavior, like forgetting something, which you said earlier, which is also called hallucinations. So here is where you actually get the control over the output. These are the two key settings. First is the temperature. It controls randomness or creativity. Let's say low temperature, close to zero, makes the model focused on consistent and predictable outcomes. So it's great for facts, remembering facts, and the high temperature makes it more random and creative, better for brainstorming stories and varied ideas. So yeah, if you are dealing with any creative task, you can set the temperature high. Else, if you are dealing with the predictable task or the facts, you can keep the temperature as low as possible. And then is max tokens. It simply caps how long the token response should be. Set it low for short answer and high for detailed descriptive answers. Since you often pay per token, it's also a cost control. Big lesson is that the same model can feel completely different depending upon how you set these dials. So how does the answer actually appear? This really surprised me. The model generates one token at a time. It looks everything so far, predicts the next single token and adds it and then repeats. So using its new output as a part of input for the next prediction. So that's it. A large language model at its core is an extremely sophisticated next token predictor running in a loop. What is prompt engineering or and context engineering? So if the model just predicts what comes next based upon what you gave it, then what you give is everything. That's where prompting comes in. So prompting is a craft of writing clear, specific instructions to get the output you want. Giving context, examples, the desired format, and the role you want the model to play. So that is basically the prompt engineering. And coming to the context engineering, it is a bigger discipline around it. So deliberately deciding what information goes into the context window and the instructions, the examples, relevant documents, conversation history. So the model has exactly what it needs, nothing distracts it. And this shift in mindset is basically you're not asking the AI a better question, you're engineering the conditions for a good answer. And recently, the loop engineering is trending right now. We'll discuss it in the future classes. So these three concepts explain where a model's knowledge actually comes from. The first one is pre-training. It is a massive first phase. The model reads enormous amounts of text, learns language, facts, and patterns. So this is expensive, slow, and done once by the model creators. So this is where the model's general intelligence is built. And then is a fine tuning. It is a smaller follow-up phase after pre-training, where you take that pre-training model and train it further, focused on the data set to specialize it. For example, a legal document or medical Q&A for your company's tone or voice. And then is a RAG, retrieval augmented generation. It is different and really clever. So instead of retraining the model, you just connect it to an external knowledge source where you ask a question. The system first retrieves the relevant documents and feeds them into the context window. So that model answers using fresh, specific, trustworthy information it was never trained on. This is how you get an AI that knows your data without rebuilding the model. Here is where the model stops being just a talker and starts being a doer. So function calling and external tools. So what is function calling? Let's an LLM connect to an external tool and code. You describe the tools available, let's say get weather or get database, send email. So let's say these are the available tools. When the model decides it needs one, instead of guessing, it outputs a structured request to call that particular function. So this is huge because it patches the model's biggest weakness. It can now do real math, pull live data, check time, query a database or take actions in real world. It's like it can do all of this at once. Like based upon the output of one thing, it can start working on the next task. So that is the function calling or the tool calling. So this is the destination of a whole course, the agentic AI. An AI agent combines everything we just covered, like reasoning, memory, tools, function calling, into a system that can pursue a goal across multiple steps on its own. So instead of you prompting once and getting one answer, an agent can plan a task, break it into steps, use tools to gather the information it needs, observe the results, adjust its plan, and repeat until the goal is done. Think of it like a difference between asking someone for the directions versus handing them the keys and saying to get us there. Now the honest part, because no good learner ignores the weaknesses. So hallucination, remember the model, sometimes it confidently states things that are completely false. So always verify important facts. So bias, model learns from human data, so they can absorb and repeat the biases in the data. Privacy, whatever you send to closed model leaves your system, and it might go to the foreign servers as well. So you need to be careful with the sensitive information. And the next thing is security. So these models can be manipulated through cleverly crafted inputs. So you can't blindly trust these models in a critical condition. So, so none of this means that models are bad. It means we have to use them responsibly with a human in loop for anything that matters. So the takeaway that ties lecture one together is the powerful tools demands thoughtful uses. So always verify the important outputs instead of trusting it blindly, and always protect private and sensitive data. Stay away of biases and double check the outcomes. So always keep a human in loop for high stake tasks. So the goal isn't to fear the technology, it's to understand it well enough so that you can use it wisely. And honestly, that's why I am taking this course. So let's recap what lecture one gave us. We saw how AI, machine learning, deep learning, and generative AI nest inside each other. And then we traced the evolution from rule-based system to today's AI agents. And we met the major models and often open source versus closed source debate. We opened the hood on tokenization, context window, temperature, and how an LLM generates one token at a time. So we also learned prompting and the context engineering. And we also saw pre-training, fine-tuning, and RAG. So we saw how function calling turns a model into doer, leading up to full agentic AI. And we faced the real the limitations of these models. So that's a solid foundation. From here, the course gets deeper into each of those topics, and I'll keep documenting every step. So if this really helped you understand generative AI a little bit better, that genuinely means a lot. Drop a like so it reaches more people learning the same thing. And module 1 week 2 is next. I would want you to drop a comment that finally clicked for you, or anything that you are still confused about. I'll dig deep into it. Thanks for learning with me. See you in the next one.
Thanks for watching. Let's keep exploring the world of AI. Don't forget to subscribe and power up your knowledge.